Alright guys, today we're going to do some practice with codominance, and you actually don't have an assignment here. This is just a lesson for you. So with codominance, we are going to be using two letters. They're both going to be capital because they're both dominant, so there will not be any recessive. For this particular example, I'm going to be using the letters B and T. We're going to be crossing between a black cat and a tan cat, which will produce a tabby cat, which is a black and tan fur together in stripes or in spots. So cross a black cat with a tan cat. And I have 3 squares, so I don't believe I actually need 3 squares. So I'll use this one here. Black cat would be 2 capital B's. The tan cat is going to be 2 capital T's. Whenever you're doing 2-letter crosses, you want to alphabetize them, so I would put my B's in front of my T's. What percentage of the kittens would have tan fur if a tabby cat is crossed with a black cat? Ooh. So down here we're crossing the black cat with the tan cat. I guess I did these a little out of order. So my genotypic ratio, I'm going to start with my 2 capital B's. I don't have anything like that. Heterozygous, I have 4 like that, and I have 0 that are 2 capital T's. My phenotypic ratio would then be the same, 0 to 4 to 0. Okay. So that was letter C. Sorry about that. Now we're going up to A. What percentage of kittens would have tan fur if a tabby cat is crossed with a black cat? So tabby is going to be one of each. Black cat would be 2 capital B's. We're looking for a percentage of cats with tan fur, and that would be a 0. I don't have any that have tan fur. What percentage of kittens would have black fur if a tabby cat is crossed with a black cat? So this is the tabby cat, here's my black cat. Same cross. If we're looking for black fur, I have 2 that would have black fur, so that would be 50% would have black fur, 50% would have tan fur. So just like with incomplete dominance, that heterozygous form is going to be a mix-up between 2 of them. But instead of it blending the colors together, both of the colors are going to show. And then down to number 2. In short-haired cattle, hair color is decided by a pair of codominant traits. Capital R is the allele for red hair color, and capital W is the allele for white hair color. A cow with a heterozygous genotype is rowan in color. So that means that it is red and white. Could be like a swirl, or they just have both hair colors. Complete the following crosses. So my cross is going to be a red one with a rowan one. My genotypic ratio, start with 2 capital R's, so I have 2. My heterozygous form, I have 2 and 0. Your phenotypic ratio should be the same as your genotypic ratio, just like with incomplete dominance, doing ratios with that. White mixed with rowan. My genotypic ratio, you start with 2 capital R's going alphabetically. I don't have any, but I have 2 heterozygous and 2 white. Phenotypic ratio, I wouldn't have any red. I would have 2 rowans and 2 whites. Rowan with rowan. So I have 1, 2 R's, I have 2 that are RW, 1 that's going to be WW. My phenotypic ratio would be the same. Would it be easier to create a herd of all red or all rowan cattle? Explain. If I wanted them to be all one of the colors, it would be easier to do red. because all cows would have red fur. If you were going to do a Rowan herd, you would need one cow that had red fur and one cow that had white fur. And you would be constantly breeding red fur with white fur. And if all these cows are out there free roaming together, you could end up with some red cows and some white cows as well. So it would be easiest to either pick between all red or maybe even have an all white herd versus trying to do a Rowan herd. A new type of animal was created through incomplete dominance. Now we're going back to incomplete dominance here. It's called a zeegle. This is a cross between a zebra and an eagle. Two zeagles meet and fall in love. What type of offspring will they produce? So in incomplete dominance, we're just using one letter. And remember, it's a blending of the traits here, whereas with codominance, they both show up. Percent of zebra children would be 25. Percent of eagle children would be 25. And zeegle children would be 50. Completes a cross of a zebra and a zeegle. Percent of zebra children, I have 50. Eagle children, there's none that have two lowercase t's. And zeegle children would be 50 again. What parents would need to be crossed to create 50% zeegles and 50% eagles? So if we're doing zeegles and eagles, my inner workings will look like this. There's my 50% zeegle, and my eagles look like that. So if I work backwards now, I'm going to move up this little t, and I'll move up this little t. Can't move up that little t. That wouldn't work out right. That would mean that I would have had to pull up this big T because the big T was dropped down. So that would mean that those ones are moved over. So you would need to cross a zeegle with an eagle. These ones we've already done through our SpongeBob exercise. SpongeBob SquarePants meeting Susie Roundpants. SpongeBob is heterozygous for his square shape, but Susie is round, and you'd be crossing them with the letter R. So I'll go ahead and do it anyhow in case you forget it. So he's heterozygous, she's homozygous recessive here. And these are done through complete dominance. Probability of having a square child would be 50%, 50%. When you do complete dominance, you only have two phenotypes. There is no blending where both of them are not shown. Patrick met Patty at the dance. Both of them are heterozygous for their pink body color, which is dominant over yellow body color. Because they are both heterozygous for their body color. Probability of having a pink body, which is dominant, would be 75%, and yellow would be 25%. So that was kind of a conglomeration of doing all three types of Punnett squares. All right, guys, that's it for this one. I'll talk to you soon.